Hey everyone, in this video we're going to be continuing our foray into trig identities and simplifying these trig identities. So very similar to the last video and the Delta Math assignment that you did, except just a few minor differences, but we're going to be using the same formulas. And I'm going to go ahead and upload this table here on Google Classroom along with this assignment so you can use this for reference. So this is just all of the trig ratios that we've learned up here, their relation, and then also what we call the Pythagorean trigonometric identities here. So these are the Pythagorean ones, and these are just the basic trig ratios up there. So you've seen all of this stuff before. This is just all the different ways that you could rewrite it. We did this in the last video, but here it is a little bit simplified for you here. So we're going to be doing a very similar procedures we did in the last video as well and on Delta Math, maybe just a little bit more complicated in that we're going to have some what we call complex fractions. So let's go ahead and dive into the first one and go from there. We're just going to be doing some example problems. None of these are exactly the same, so it's just kind of practice figuring out what to substitute in and then just simplifying it until we get these down to a single trig identity or a constant, which is the same goal that you had in that Delta Math assignment. Let's go ahead and go with our first one. We're supposed to simplify tan theta cosine theta. So first of all, we need to choose which one we're going to replace. Well, you have two options. You can either replace tan or cosine. The obvious choice here is tangent, because if you think about what tangent has in it, it has a cosine in it. So generally, we're going to try to get something to cancel out. So if we replace tangent with sine theta over cosine theta, and then we've got it times cosine theta, well, that's good because then we've got two of the same terms there, which do in fact cancel. And so our answer is just sine theta. It is important that you're showing your work on these. You cannot just write your final answer sine theta. I'm not going to give you credit if you just write the final answer. So very important that you show what you substituted. I would actually even put this in parentheses just so we can show that we substituted tan with sine theta over cosine theta. Okay. If you were to substitute cosine theta, you would get, well, really only one option, 1 over secant. And then you have tangent times 1 over secant, and that just doesn't help us at all. So, all right, let's look at the next one. We've got 1 minus cosine squared over cosine squared. Probably as another general rule, anytime you have like a 1 minus something, you want to try to replace that part. So I'm going to go ahead and try to replace this part because we don't really want any like addition and subtractions. If we can get rid of those, that's going to make things easier for us. So a substitute that I have for 1 minus cosine squared is right here. 1 minus cosine squared is equivalent to sine squared. So this is actually equivalent to sine squared theta over cosine squared theta. And then, might not be immediately obvious from this point, this one isn't necessarily on here, but we do know that sine over cosine is tangent right here. So if both of those are squared, it's also true for this one that tangent squared, so you might even want to add this, tangent squared theta equals sine squared theta over cosine squared theta. That is also true. If tangent equals sine over cosine, then tangent squared equals sine squared over cosine squared. So this is just tangent squared theta. That's our final answer. So hopefully that's clear. Anytime you see the squareds, you can always replace those with the single if they're both squared. All right, let's go and look at the next one. Cosine theta times cosecant theta. All right, so let's look at what options we have. We can either replace the cosine with 1 over secant. If I were to do that, 1 over secant of theta times cosecant of theta, you can actually still solve it this way, but probably doesn't make a lot of sense maybe to do that. It doesn't really matter, but if you do it this way, you would then just multiply this. So this would become cosecant theta over secant of theta, right? And then this one actually is a trig identity as well. Cotangent, which actually we don't have this derivation of cotangent. All right. So I'm also want to, oh, there it is. Where is it? All right. Yeah, so this one isn't necessarily on here, but I'll show you how it works out. So we would then have to replace cosecant with 1 over sine of theta over 1 over cosine of theta, right? And then you have to end up doing some flipping and multiplying, and this ends up as 1 over sine theta times, we flip the bottom and multiply, cosine of theta over 1, so then we get cosine of theta over sine theta, which is a trig function that we know, cotangent of theta. So what I was going to say here, you could add to this for the cotangent of theta. This is also equal to what we saw down here, cosecant theta over secant theta. If you wanted to add that, good. Could add that next to it. You don't need to, but if you want to, you can. All right, now the other way of doing this is probably a little bit simpler. As a note, there's always more than one way to solve these. You might not find the easiest way. If I were to instead replace cosecant, so I'd have cosine theta, and then I replace cosecant. Cosecant is 1 over sine. It's right here. So 1 over sine theta. Well, then we just multiply. We get cosine theta over sine theta. And that we can see cosine theta over sine theta is just cotangent theta. So that is significantly easier way to go about doing it. It'll save you a lot of steps there and also some complex fractions as well. So either way, we get cotangent of theta. Make sure you're showing your work again so I can see how you did it. If you just write cotangent of theta, I'm not going to give you credit for that. All right, let's go and look at our next one. Oh, as another general strategy, this doesn't always hold true, but if you can write everything in terms of sines and cosines, that generally works out well for you. It generally helps. I won't say always, but generally that helps. So if we just take this last problem as an example, in the first method here, I wrote it instead of changing this to sines or cosines, right? I actually changed the cosine to something more complicated, right? And it ended up being a long problem. Whereas method 2 here, I left the thing that was in cosine as is, and then I changed this to a sine thing. So I changed everything to sines and cosines. It generally works out better for you in that respect. So it's just, again, a general strategy. Doesn't always hold true, but most cases it does hold true. Same with this first problem. You can see here I changed tangent to sine and cosines, and that made it really easy to solve it. If I had changed cosine to something else like 1 over secant of theta, that would have made things a lot more challenging for me and would have been more steps to solve it. So as this general strategy, you might want to make note of that. All right, so with that in mind, let's go ahead and do that for the next one. So sine of theta, I'm just going to keep as sine of theta. Secant of theta, well, if you have trouble with that one, secant is 1 over cosine. So I'm going to go ahead and change that to 1 over cosine. In tangent, I could leave as is, but I'm going to take the strategy and I'm going to go ahead and change tangent to sine over cosine, because that's what tangent is, right? Tangent is sine over cosine. So I'm going to go ahead and make that substitution as well. It might look like we're making things more complicated, but in the end, this is going to help us. All right, so you can see my 2 substitutions there. So my next step, I'm just going to multiply this top. This just kind of goes up there because it's sine of theta times 1. It's just sine of theta over cosine of theta over sine of theta over cosine of theta. Now you might actually see at this point, this answer is just going to be 1 because we have just the same thing over itself. Anything over itself is always 1. Now, if you didn't see that, what you would do, this is called a complex fraction because it's a fraction within a fraction. You're going to keep the top one as is, sine theta over cosine theta. We're going to multiply by the bottom flipped. So we flip it, it becomes cosine theta over sine theta, multiplying by the reciprocal, in other words. And you'll see we get cancellations. These cancel, so we're not left with 0, we're left with 1, constant 1. So either way, if you were able to recognize that or not. There it is. Okay. Again, this just takes practice, but if you stick with this strategy, most times it'll pay off. I'm going to go ahead and just do a few more here. These are all going to be complex fractions. So same table of values here. Again, I'll upload a picture of this on Google Classroom as well. So let's take this strategy of just changing everything to sines and cosines and see how it works out for us. So our first one here, we're going to go ahead and replace cosecant with 1 over sine. Here. So 1 over sine of theta over cotangent. Now, cotangent, we're going to use this version of it instead of this one. Over here, where it's 1 over tan. We don't want to do that. We're going to do cosine theta over sine theta. Because remember, we want to get everything in terms of sines and cosines. Okay, so now we have a complex fraction. It might look like we just made things way worse, but this is going to help us because we're going to keep the first one, the top, 1 over sine theta, multiply by the bottom flip, the reciprocal, times sine theta over cosine theta. Generally, always we'll get a cancellation, which we can see diagonally those cancel. So we're left with 1 over cosine theta. Now we can't leave it like that though. It is a single trig function, but it's 1 over a trig function. This is an easy substitution though, because 1 over cosine theta is just secant theta. So that equals secant theta. Again, make sure you're showing your work for that. For our next one, 1 minus cosine squared. Let's go ahead and replace that with something if we can. 1 minus cosine squared is equivalent to sine squared. So I'm going to go ahead and do that. Sine squared theta. And then tangent of theta. Again, let's go ahead and replace that with something that's not necessarily on here, but remember how I said that tangent squared theta is the same thing as sine squared over cosine squared, right? So let's do that. So sine squared theta over cosine squared theta. Now we're going to just keep flip, keep the top, sine squared theta. You could say over 1 if you want to. Times we flip the bottom, cosine squared over sine squared. And we'll get the cancellation we're looking for. Sine squareds cancel. And it leaves us with just cosine squared theta over 1, which is just cosine squared theta. So that's our single trig function. It's kind of crazy, right, when you look back, how 1 minus cosine squared over tangent squared actually is just cosine squared. To me, it's at least a little bit kind of cool, right? Let's go ahead and try 2 more. Take our strategy of turning everything into sines and cosines. So we'll keep our cosine. We'll change secant with 1 over cosine. And then we'll trade tangent with sine theta over cosine theta. So from here, the cosines cancel in that top because when you multiply, those are just going to be diagonal. So we end up with just 1 over sine theta over cosine theta. So for this one, we just want to flip and multiply. So it's just going to become 1 times cosine theta over sine theta, which of course is just cosine theta over sine theta. Doesn't change. Then we need to get this to a single trig function. So there is one that is cosine over sine, and that is cotangent. So that was going to be our answer, cotangent theta. Again, showing all my steps, things I replaced. And our last one here, the top is already in sine, so we're just going to keep it as sine of theta. The bottom is cosecant, which is 1 over sine theta. If you need to keep referring to this chart, don't worry about that, right? I don't expect you to have all of these memorized by now. I have them memorized, but you might not. I've been teaching math for a while. So if you don't have them memorized, that's fine. Always just look at the chart. All right, and then we flip and multiply sine theta times, we flip, it becomes sine theta over 1, which this, when we multiply, is just sine theta times sine theta is just sine squared theta. Over 1 would just be the same as sine squared theta. So that is our final answer for that one. Again, all of these we've just simplified to a single trig function. It's allowed to be squared, that's fine. We ended up with our last one. Do the best that you can on these. If you are struggling with one in particular, you can reach out to me, or just do the best you can. At least show some work. Show me that you tried to figure it out. Maybe you couldn't figure it out, but I need to see some work for all these. All right, that does it. Good luck on those problems. You're going to have 8 problems, I believe. Yeah, 8 problems. Same thing we just did. It's about exactly the same thing. The last 4 are going to be complex fractions. The first 4 may or may not. All right, good luck with that.